Hi Math 6-5, this is lesson 103, which is for the last lesson of March 30th. And it deals in volume. If you remember back, we've discussed geometric solids, or some people call them 3D, three-dimensional shapes. What I've drawn on my paper is like a two-dimensional square and a two-dimensional rectangle. They are flat. They're on a what's called a plane because it's on a flat surface that goes on and on and on forever. And they just sit on the paper. They have a length and a width, but they don't have any height. They don't come off the paper at all. They're just what's flat and drawn on the paper. In contrast to like our cube and our rectangular solid, these guys not only have a length and a width like our square on the paper, it has this height. It comes off the paper. And so it takes up volume. Its volume is the amount of space it occupies. So the volume of this cube is the amount of space that this little cube in my hands occupies. So the same with the rectangular solid. It's not just flat on the paper like the one I drew. It is not two-dimensional. It is a solid geometric shape. And it has a length and it has a width, but it also has height. It comes up off the paper. So when we measure volume, we measure it, and when we write down the volume of something, we write it in what's called cubic units. So if, for example, units, it could be cubic centimeters. If we did that, there's centimeters, cubic centimeters. We've done exponents, so it's centimeter with the cubed symbol, cubic centimeters. If it was cubic inches, that would look like inches with that exponent of 3 to be cubic inches. The reason that there's an exponent of 3 we'll explain in just a minute when we get into how to determine what the volume of a geometric solid is, which we're about to do. So basically we're trying to figure out, like, if we were measuring this cube in cubic centimeters, we'd be trying to figure out how many 1 centimeter cubes would fit inside this cube. Okay, and your book does a good job of having some pictures of those to explain how that looks. You can see, like in this picture, you're trying to figure out how many 1-inch blocks that are 1 inch by 1 inch by 1 inch would fit inside this cube. How many because this is the unit centimeter, so how many 1 centimeter blocks fit inside this rectangular solid? And that's how you find the volume. So the volume, that when we find it, we use the length times the width times the height. So for example, here we have 3 centimeters worth of length. So 3 times 2, which is 6. And then remember, it comes off the page, height of 2 centimeters. So 3 times 2 is 6, times 2 is 12. So we would say this is 12 cubic centimeters. So your book writes it like this, 12 cubic centimeters, but I know some of you aren't a big fan of writing all those words. So if you wanted to write it on paper as 12 cm cubed, that would be okay. Now, for the reason that it's centimeters cubed, remember, an exponent tells us how many times we multiplied something by itself. Here we multiplied centimeters once, times centimeters twice, times centimeters 3 times. So that's why it is cubed. Remember, when we do area, it's just length times width, so it's squared because it's centimeters times centimeters. But when you do volume, you're adding in a third number, so it's centimeters times centimeters times centimeters, which is centimeters cubed. Okay? So basically, if we were going to write it as a formula, it would be the volume equals length times width times height. Make sure that's getting in there. Length times width times height for these objects. So when you go to your practice problems, everything is laid out pretty simple as far as this formula, and your volume is going to be in units. I'm writing units, but remember you would replace units with centimeters or inches or feet or whatever unit your problem gives you. So let's do a couple practice problems together. Okay, your practice problems are located on page 534. So let's start with letter A. Okay, so if we look at our solid on A, let me bring that on screen, we see that it is 4 inches long, has 4-inch blocks across, 2-inch blocks wide, and 4-inch blocks high or tall. So we are going to just plug that in to our length times width times height. And when we do that, we have a 4 times 2 times 4. Okay, and each of those are in inches. Okay, so when we do the math on that, 4 times 2 is 8, times 4 is 32 inches, and we did how many times? 1, 2, 3, cubed. 32 inches cubed. That is the volume for A. Okay, so if we look at, then let's just go and do, so B, C, D, E are all the same exact one, just different numbers, different shapes, but the same exact principle. So let's go to F, because it is the first one that's a little bit different, not much. So for F, again, I'm on page 534 still. Let's see, the cracker box was 2 3/4 inches wide, 5 1/4 inches long, and 7 7/8 inches high. Let me bring that on the screen just so you can see where I'm at. Okay, I'm right here reading this problem. So it gave us all these dimensions of the cracker box, of the Saxon saltines. Yummy, yummy. What is the approximate volume of the box? Now, we're going to go back a lesson or two, and we're going to, when something is approximate, it's like an estimate. So we estimated, not this last lesson, it was 101. We estimated, we took mixed numbers and we rounded them. And that's what we're going to do here first before you find the volume. Okay, so you have to look at your mixed numbers you have, and you have 2 3/4 inches, you have 5 1/4 inch, and you have 7 7/8 inch. So now you have to estimate what those are going to estimate to, what those mixed numbers will estimate to. Since you have already done a whole lesson on this, I'm not going to draw the number line and spend all the time doing that. I'm just going to estimate them for you. If you need to draw your number line, please draw your number line. It's okay. So 2 3/4, when I round that, I know that is closer to 3 inches than it is to 2 inches. 5 1/4, I know is closer to 5 inches than it is to 6 inches. 7 7/8, I know, is closer to 8 inches than it is to 7 inches. So these are my rounded numbers that I'm going to be dealing with. So then I'm just going to go back to what I know and have been doing the prior, 5 problems, which is length times width times height. And I'm going to plug these in. So I have let's say 5 1/4, which went to 5, times my width of 2 3/4, which went to 3, times my height of my box, 7 7/8, which rounded to 8, and all of these are inches. So I have 5 times 3, which is 15, and 15 times 8, you can come over here and work it out. 5 times 8 is 40, carry your 4. 8 times 1 plus 4, 120, okay? So I know that 120, because I have 5 times 3 was 15, so I did these two, 15, and then times 8, did my math over here, to get 120, and I know my units, going back to my problem, my units are inches, and I know I'm doing volume, so I multiplied it 1, 2, 3 times, so it's inches cubed. Okay? So you can finish off those practice problems for this lesson, and if you have any questions, let me know. There will be more videos that will come out for Thursday, I think it's April 2nd. I could be wrong on that. Whatever the Thursday is after March 30th. Let's see, 31. Yeah, I should be April 2nd. There'll be more videos for that. And if you need any help between now and then, let me know. Also, make sure you have turned in you can turn it in email, text, or Google Classroom. Turn in your week 8 work. And make sure that just all I need is the signed and completed assignment sheet. I don't need all the stuff behind it. Just have your parents send me that signed assignment sheet and completed. So, hope you're doing well.